In PreCalculus, DeMana's 7th edition, section 5.6, Law of Cosines, problem 13, A equal 42 degrees, opposite side equals 7, B equal 10. First of all, we note that this is an SSA triangle, in which the side opposite A is smaller than the other side. So we would expect two solutions. Putting this into the law of cosines, we have a squared is equal to b squared plus c squared minus 2bc cosine a. Solving for c, we have an equation c squared minus 2bc cosine a plus b squared minus a squared is equal to 0. C squared minus c times 2 times 10 cosine 42 degrees plus 10 squared minus 7 squared equals 0. C squared minus 14.1421c plus 51 equals 0. Solving this by the quadratic equation, we get the two solutions for C, 9.487 and 5.376. Now, solving for the angle B, we have b squared from the law of cosines is equal to a squared plus c squared minus 2ac cosine b. Solving then, we get the cosine b is equal to a squared plus c squared minus b squared over 2ac. We have two values of c. If we take the first value of c and plug it into here, we get b equals 72.9 degrees. Maybe we call this b1. And then c1 would just be 180 degrees minus 72.9 degrees minus 42 degrees is equal to 65.1 degrees. Now look at the second solution. We'll call it C2 equal to 5.376. Again, the cosine of b is equal to a squared plus c squared minus b squared over 2ac, where now this would be C2. If we solve this, we find that the angle B is equal to 107.1 degrees by taking the arc cosine of this quantity. Then in this case, C2 would be 180 degrees minus 107.1 degrees minus 42 degrees, or 30.9 degrees. Summarizing again, this was an SSA case, and in this particular case we had two solutions and we found them. We had a B2 second angle here, and we had a C2. We had two values for C. We have a C1 and a C2. In problem 25, I've saved some time by writing down the equations, but we use Heron's formula for a triangle of sides A, B, and C. 19.3, 22.5, 31. In Heron's formula, we find the semi-perimeter, which is A plus B plus C, the perimeter divided by 2, and we get 36.4. In Heron's formula, then, the area of the triangle is this quantity S, the semi-perimeter, times S minus A times S minus B times S minus C. Plugging those numbers in, S minus A, S minus B, S minus C, and taking the square root of everything, we get 216.15. In problem 31, we have a regular hexagon, meaning equal sides, equal angles, inscribed in a circle of radius 12 inches. In this picture, we've drawn the circle, radius 12 inches along either of these axes, and divided it up into 6 equal sides. Here we've redrawn it. Since there are 6 equal sides, the angle would be 360 divided by 6 would be 60 degrees. So each angle of the triangle is 60 degrees. In general, the area of the triangle be 1/2 BC sine A. It does not matter how we label it, since all sides and all angles are the same, so we would have 1/2 times 12 times 12 times the sine of 60 degrees. A 60-degree angle looks like this: 1, 2, square root of 3. This is equal to 1/2 times 12 times 12. Sine of 60 degrees would be the square root of 3 over 2. And we get 62.354 square inches. But there are 6 sides, so we multiply this by 6, and we get 374.1 square inches for the area of the regular hexagon. In problem 38, a surveyor finds the distance from A to B across opposite sides of the lake. There is a lake drawn in here, but it really doesn't matter because in the end we're really only solving for this triangle A, B, and C. We're given this side to be 860, the angle here to be 78 degrees, this side to be 17.5. With the notation I've used of A, B, and C, we have A 175 feet, B 860 feet, and C 78 degrees. And we notice that this is a side angle, side angle, side triangle. Using the law of cosines, this side would be little c. We have c squared is equal to a squared plus b squared minus 2ab times the cosine of c. So c is equal to the square root a squared plus b squared minus 2ab cosine c. C is equal to the square root of the quantity 175 squared plus 860 squared minus 2, 175, 860 times the cosine 78 degrees. And this would be 841.2 feet. This turns out to be a really easy problem. It's just a triangle, but it's given the problem with the lake and makes it look harder. So always look at word problems and boil them down to their simplest explanation, which is just find the side of this triangle, find C.